Okay, you guys, so I wanted to be ready for this overview for you. This document, I don't expect you to read it, but I'm linking it in anyway because, for transparency, this is what I get to see as a teacher. And actually every teacher in the district has this. And these are all of the priority standards you are supposed to know by the end of the year. So I want to just point out a couple that you've already learned. You are supposed to, identify the effect of the graph by if you zoom in here, if you add a number to the outside, if you multiply a number, if you add a number to the inside for specific values of k, you guys know that those are graph shifts. So we've already actually hit the standard. You're good at this already. Inverse functions, we did technically learn that. Down here you have things like vertical angles are congruent when a transversal crosses parallel lines. Alternate exterior are congruent. Corresponding. Oh, I'm thinking of you guys. That's the gang sign. Points on a perpendicular bisector, whatever. So we didn't do all of these, unfortunately. This is all from last semester. But if you read through it, those are all last semester things. We are focusing on this. This is what you've been working on since I've left. Oh, no, not that. But all of this quadratics, we are solving a quadratic like that by taking square roots, completing the square, quadratic formula, and factoring. So this standard, I'm going to click into this, has an entire page for you. This is the most important thing. This is what your score would be if I scored you on this learning intention. So if you just received a score out of 4, if you're a 1, you didn't really learn anything. If you're a 2, a 3, or a 4, well, let's look at the 2. Hey, students, do you know this vocabulary? Like, do you know what a quadratic equation is? Do you know what the quadratic formula is? Do you know what factoring is? Completing the square. When I say solutions, do you know what those are? Double roots, we barely touched on that. And then imaginary numbers, that was in my last video. So the basic processes are setting the equation equal to 0, identifying the C value, so you can complete the square, methods of factoring, and learning the quadratic formula. I knew when I left that this would not be perfect. I also know that many of you have it in you to know how to do this, at least on a basic level, receiving a 2, a 2.5, or a 3. I'm not going to worry about score of 4, but I'm going to ask you guys to take some notes so I can tell you exactly what these bullet points mean. Solving a quadratic by taking a square root, by completing the square, by factoring, and by quadratic formula. These are the notes for today. So if you'd like to refer back to this, this is what I'm about to get at. So I like to have an intro for you guys. You'll see this is the back of a paper, so there are some pictures of compasses on the back. Ignore those. So sorry that also I'm holding my phone. Solving quadratics. Okay, there is my favorite example. This could go in your tiny notes book. It could also go on a larger piece of paper. But my favorite thing to explain to students is there's a reason this is hard. There's a reason solving quadratics takes months to learn. And that's because if I have x squared plus 5x minus 6 equals, I could make it equal to 0 like you're used to, or I could make it equal to anything. Would you believe me if I said you cannot do this? You don't know how to solve this. The reason you're in math 2 is to learn how to solve this. So I've done this already for you, but this is my just like stupid example that is the reason that we cry. I just like to make sure that my students understand this. I freaking dare you to try to solve this right now. By isolating x at least. What the hell do you do next? Sorry, I cussed. What do you do next? Try it. I dare you. You can't do it. So we have methods to figuring out how to solve this. I would like you to take notes. I'm going to give you an example. Our first method is actually that it's only impossible if you have an x squared term and an x term, because you're going to just be like dividing or square rooting until the day that you die. You're never going to be able to separate these. So method 1 is actually, it is possible This is our easiest method if we don't have both of these terms. So method 1 is isolate x, but this only works if it's in vertex form. Only works sometimes. So your example are the ones that you've been doing lately, which are from vertex form. Let's say you have the equation x minus 1 squared equals 49. So this is a simple vertex form. It's not equal to 0 yet, so technically the 49 is the wrong vertex form. I guess the second example would be x minus 5 squared minus 4 equals 0. So this is shifted left 5, sorry, oh my God, right 5 down 4, and then right 1, that would, it's off because we're supposed to set it equal to 0. But you can solve this by doing inverse operations because there is only one x. So we can't isolate this because the only x is right there. This only x is right there. These ones you can do it, thumbs up, but this one there's an x here and an x here, so you can't do it. So we're gonna ignore that, that one's not right. If you tried to isolate x to get rid of the squared, you would square root both sides. The square root of 49, well, 7 times 7 is 49, or -7 times -7 is 49. So this is when you have to do plus or minus 7. So it's possible to write plus or minus 7 like this. That's how mathematicians write it, but you just need to make sure you know that that's two separate equations. So by square rooting this, that's gone, and I have x minus 1 is out by itself. Could be +7, or x minus 1 could be -7. Now we solve each of these with just isolating x. I can add 1 to both sides. Add 1 to both sides, and then I get, let's see, that cancels. 7 plus 1 is 8, so either x equals 8 or x equals -7 plus 1, -6. And you can check your work and plug it back in, and you'll know that that works. For this one, this is actually a more classic vertex form. You could add 4 to both sides first. That's what you're supposed to do. That's what you've been doing. But typically you do see these equal to 0. So you'll need to get rid of that graph shift to the other side. That's a 4. X minus 5 squared equals 4. And I'm going to leave it there. You should do this in your notebook the same way I did this one and make sure you get 2 different answers. Your answers in the end should be 9 and, nope. God, I'm sorry. I'm trying to do this in my head without doing the work, and it's not, obviously didn't work out for me. 7, your answers should be 7 and -4 plus 5 is 1. Okay, that's method 1. That's the one we've already been working on. Now, method 2 is called zero product property. And this, I think I'm gonna focus on this right now. There are 3 methods, but zero product property is mostly, so only works sometimes. We're gonna call this like vertex form especially. Vertex form. Zero product property only works in factored form. So if you have a factored form equation, you can't isolate x this way. You have to do something else. So I know you guys have done this before. What's factored form again? These are parentheses. Factored form has parentheses. So I'm going to give you this example here. The zero product property in factored form, x minus 5 and x plus 1. So this only works if it equals 0. So if I have this equal to 1, this is not going to be possible, but I'm going to ask you guys to actually do this equation out here with me. Let's say we have the equation equal to y. So stick with me here. This is 2 numbers multiplied by each other. So I'm going to actually have us make a table, and I'm going to plug in some x values and ask you guys to like see what happens. So we have -1, well, I'll do -2, -1, 0, 1, and 2. We're going to just plug in some numbers and see what our outputs are. So for this function, if I plug in -2, I'm gonna leave some space for some math before I get my output. If I plug in -2, and I do -2 minus 5, so I'm plugging it in right here, and -2 plus 1, what's my output gonna be? Well, -2 minus 5, I do parentheses first, that's -7. -2 plus 1 is -1, and then I multiply them. -7 times -1 is 7. So my input and my output is an XY pair. That is a coordinate point. So -2, 7 would be on this graph. There is a reason I'm making you do this. When you plug in -1, you get -1 minus 5, -1 plus 1. I sure hope you guys aren't fast forwarding through this. -1 minus 5 is -6. -1 plus 1 is 0. So -6 times 0 is 0. So we have -1, 0. Plug in 0. 0 minus 5 times 0 plus 1 is -5 times 1. That's -5. 1 minus 5. Oops. And then 1 plus 1 is -4 times 2, which is -8. 2 minus 5 times 2 plus 1 is -3 times 3 is -9. I sure hope that's right. I sure hope I didn't do any math wrong. -5 times 1. That seems okay. I could check Desmos if I needed to. But all of these coordinate points now, 0, -5, 1, -8, and 2, -9. This is important because do you see we've just found some intercepts? So I usually ask you guys to identify the intercepts from a graph, but we haven't graphed this yet, and I can already tell which one are the intercepts. Can you see which two are the intercepts if I were to graph this? Because they are here and here, where there is a 0. So if I graphed this, I do -1, 0, that is an x-intercept. If I graphed 0, -5, I'd go 0, -5, that's a y-intercept. And my parabola does end up looking something like that if I kept graphing. So 1, -8, 2, -9. And I only have half, oh God, I'm sorry, I wasn't even zoomed in on the right thing. So I only have half of a parabola right now, -2, 7. And so I would maybe need to put in some more coordinate points to get the whole parabola. I only really did half of the arm, so who knows where the axis of symmetry is. But now maybe you can see that what happened when I plugged in -1, because this x-intercept is the most important thing. That's the solution. Please remember, we are solving quadratics. We are looking for the solution. That's the x-intercept. So this is very important. And the reason it's giving us a 0 is that when I plugged in -1, I got 0. What's anything times 0? It's 0. So without doing a table every single time, the 0 product property says that when you multiply two numbers together, these are called factors, if one of them is 0, the whole thing will be 0. So we just saw that if we plug in -1, we get -6 times 0, and that's 0. So x equals -1 would work if we solved setting this equal to 0, because when you plug it in. So I'm gonna ask you guys right now, is there a second number that if you plug it in, you're gonna get out 0? There is, and the answer is 5. Because if you plug in 5, you get 5 minus 5 times 5 plus 1. 5 minus 5 is 0, and 0 times 6 is 0. So what we're looking for is one of these two numbers to be 0, so the whole thing zeroes out. You might have noticed these are our R1 and R2 values. But what happens with 0 product property is they aren't always whole numbers. So 0 product property, I'm going to give you a worksheet on this, says that if you have x minus, I shouldn't have done 5 because I just did that, x minus 6 times 2x minus 1. If this is our factored form, and we set it equal to 0, that's the only way we can solve it and figure out where y equals 0, which is the x-intercept. So if you can do this in your head, what number would I plug in to make this factor 0? So the method you should use if you're a method person is you are going to see where x minus 6 equals 0, because that would make the whole thing go to 0. Or you're going to see where this factor equals 0, because if 2x minus 1 equals 0, something times that was the whole thing's going to close, cancel, be done, equals 0. So we're going to see, you might have figured out this is our positive 6. So remember when we used to just switch the sign? Like if it's x minus 6, we know that r1 is positive 6. This is why. The reason it's positive 6 is because when you plug it in, it zeroes out. Whoa, there was a reason for that the whole time. Now, when there's a number in front of x, you can't do that. So when there's a number in front of x, you can't just say, oh, it's the opposite of that. So this is positive 6, but you can't just take the opposite of 1 because there's a 2 there. So I'm going to do the math out here for you. 1 plus 1 plus 1. If there's a number in the front, that's your cue that it's a decimal. So x doesn't equal 1, 2x equals 1. How do we get rid of a times 2? If we're isolating x, we divide by 2. X is actually equal to 1/2. So if you were to graph this in Desmos, this equation in Desmos, you would get a parabola that is happy, that crosses through 6 and 0.5. The parabola would cross there and cross there, and that is the answer. Oh my God, I'm sorry, my wrist is getting tired. And so that wasn't even in frame. I'm really bad at my job. There's only so many times I have something to like rest the phone on. But anyway, that's that, and this is zero product property. If you would like to finish out your notes, I am going to show you method 3, and I'm gonna ask you guys to just focus on zero product property after this today. But your third method is what happens if it's not in vertex or factored form. So what's our third form? So vertex, you can isolate. Factored form, you can just set them equal to 0 separately and just find that x value and you're done. So actually that's really simple. Method 3 is what happens if it's in standard form or general form. If it is in standard form, 2x squared minus 5x plus 1, your only option is the quadratic formula. So if you don't want to do the quadratic formula, there's also ways to learn how to just change this to vertex form or just change this to factored form so you can do methods 1 or 2. If you like methods 1 and 2, you can just change this. But without changing it, you can't do it. Like I told you at the beginning, you can't do it. The only way you can do it is by the quadratic formula. So the quadratic formula is just a formula that you plug A, B, and C into. So first, to do the quadratic formula, we need to identify, so our example would be 2x squared minus 5x plus 1. Our example, we can do after I write the quadratic formula for you. So if this is in your notebook or your tiny notes, the quadratic formula, of course, also is Googleable. The quadratic formula says that the x-intercepts, to find x, you have to plug in negative the b number, so the opposite of the b number, plus or minus, so that means there's 2 options, the square root of the b number squared minus 4 times a times c multiplied. All of that divided by 2 times a. That's it. You can Google it. It looks complicated and there are a lot of room for mistakes here, but it's not as complicated because if you know A, B, and C, you just have to plug them in. So for this one, A, B, C. A is 2, B is -5, C is 1. I really hope you remember this because I taught it to you before I left. Now that we have these three numbers, we are just going to substitute them in where they belong, making sure that I don't miss any symbols or parentheses. So to find my x values, I have to do negative b. In this case, b is -5. So it's -5. And then I'm going to add or subtract the square root of b squared. My b number is -5. Minus 4, it's always a 4, times the a number, times the c number, and all of that is divided by 2 times the a number, 2 times a. All of this now, you can put it in a calculator, but it's not easy to make sure you're missing, you don't want to be missing anything. So you are supposed to be doing maybe like PEMDAS here. You're going to simplify it one step at a time, or if you think you can do it more than one step at a time, that's also an option. So -5, I'm going to simplify that. That is just +5, plus or minus. This whole square root is my PEMDAS, so I'm going to do, let's see, -5 squared. -5 times -5, +25. Do not forget the parentheses. Please don't make this mistake. +25 minus 4 times 2 times 1. Let's see, 4 times 2 is 8. 8 times 1 is 8. So -8 divided by 2 times 2 is 4. So now it's a little bit simpler. We're going to simplify it down like an upside down pizza. Now I'm going to do 25 minus 8. Let's see. 5 plus or minus the square root of 25 minus 8 is 17. Yeah. I'm so bad at math. Divided by 4. Now, this is when, if this is a whole number, you can take the square root. So if this was a 16, you know the square root of 16 is 4. But this is not 16, this is 17. So this is a decimal, and you will need a calculator. Typically, for the quadratic formula, we are not working with whole numbers. Typically, the quadratic formula is our last-ditch effort to solve this if we can't solve it any other way. So I'm going to ask you guys to use your calculator. We're going to do two different equations, 5 plus this decimal divided by 4, and 5 minus this decimal divided by 4, because there's always two numbers. X equals 5 plus the square root of 17 over 4, and 5 minus the square root of 17 over 4. This is your last step, is just plug this into a calculator. The square root of 17 is 4 point something, like 4.1 something. So 5 plus that thing divided by 4, and it's like 9 point something divided by 4, which is something else, I don't know. And then 5 minus 4 point something is like -1 point something divided by 4. And that's something else. And you'll get approximate answers. So those approximate answers, if you want to check your work, check on Desmos. So if you aren't sure that you did this correctly, at the end of the quadratic formula, you can plug in this initial equation, and on Desmos, it will show you the x-intercepts. They will be decimals, and you're hoping that you came up with the same exact decimals. And those are the three methods to solve